In physics, we use kinematics and our problem solving is in motion. This is an example of how using some of those equations. We have been using the equation V equals d over t. This is the basic equation. Now we are going to introduce the other equations. Velocity final equals velocity initial plus acceleration times time. Velocity final squared equals velocity initial squared plus 2 times acceleration times displacement. Our displacement is equal to 1/2 acceleration times time squared plus velocity initial times time plus the original displacement. So let's look at a problem. Let's say Georgia is jogging at a velocity of 4 meters per second when she accelerates at 2 meters per second squared for 3 seconds. How fast is Georgia running now? So what do we know? We know she is traveling at a velocity of 4 meters per second. This is initial. We know she accelerates, and she accelerates at 2 meters per second squared. And we know she does this for a time of 3 seconds. We are wanting to find what? How fast she's running now. So we're wanting final velocity. So we know velocity initial, acceleration, and time. We're wanting final velocity. There is only one equation that has that. And velocity final equals velocity initial plus AT. So we know initial velocity is 4. We know acceleration is 2. And we know time is 3. So that's 4 plus 2 times 3 is 6. So that's 4 plus 6, or 10 meters per second. So final velocity is 10 meters per second. Let's try another problem. In a football game, a running back is at the 10-yard line and is running up the field towards the 50-yard line and runs for 3 seconds at 8 yards per second. What is his current position? So we know he's starting here at the 10 and he's running. And we know he's running. We don't know initial velocity. Okay. We do know his acceleration, and that is 8 yards per second. And we do know time. Okay, we know that's 3 seconds. Okay, and we know he's at the 10-yard line, so that's our original location, our original displacement. So that's 10, our initial. Okay, these two, same thing, different name. So we have an equation that we don't know initial velocity. They don't give it to us. So we're going to assume it's 0 to make the math a little easier on us. Okay, so now we're hunting final. Where are we at in the end? And there's only one equation that does that, and that's distance is equal to 1/2 AT squared plus VIT plus DI. We know this is 0. So that means D is equal to 1/2 8 times 3 squared plus 10. So that's 1/2 of 8 is 4. 3 squared is 9 plus 10. So 4 times 9, that's 36 plus 10. So he is at the 46-yard line. So he's traveled 46 yards. So let's look at another one. An alien spaceship is 500 meters above the ground. So here's our ground. Here's our little UFO. And we know this is 500 meters. It is hovering at a constant velocity. So we know our velocity is 150 meters per second. And is going up. Okay? They say it's a constant velocity. So constant velocity means no acceleration. Okay? So the question is, how high above the ground is the ship after a time of 5 seconds? So back to our equation. D equals 1/2 a t squared plus v initial t plus d initial. We know acceleration is 0. So that means d is equal to v initial. We know that's 150. We know time is 5 plus 500 is our initial distance above the ground. So that gives us 150 times 5, 750 plus 500. So that gives us 1,250 meters above the ground. So let's look at a bicyclist is traveling at 25 meters per second. So we know initial is 25 meters per second. And he begins to decelerate at -4 meters per second squared. So he's decelerating, that's acceleration, in the negative direction, 4 meters per second squared. And how fast is he going after 5 seconds? So we know initial, acceleration, and time. We're wanting final velocity. So velocity final equals velocity initial plus AT. Put in what we know. 25 plus -4 times 5. So that's 25 minus 20. So he's now traveling at 5 meters per second. This is basically how you do all the problems. There's only one equation, which I did not do, and velocity final squared equals velocity initial squared plus 2AD. So, good luck in doing the problems. And if you have any questions, email me.